All right, welcome back. These were the two problems that you were supposed to do on your own from your Canvas. If you haven't done them yet, shame on you. Go back and do them, okay? Don't look at the answers first. Get some practice. So we're seeing if these ordered pairs are solutions to this inequality. Do they make true statements? So I'm going to replace the x and the y in the inequality. And then I'm going to see if the result is a true statement. So this is 0 plus 8 is less than 6, which means 8 is less than 6. True statement? No. 8 is not less than 6. 8 is, in fact, larger than 6. This is false, which means it is not a solution. It is only a solution if it makes a true statement. What about 2, 2? We're going to replace 2, 2 in that inequality. And we're going to see if this makes a true statement. This becomes 10 minus 4 is less than 6, which is 6 less than 6. Is that a true statement? No, it is false. 6 is not less than 6. It's equal to 6, but it is not less than 6, which means this is not a solution. Okay, so this is finding solutions, or testing solutions, I really should say. Does this point make a solution? So if you got any troubles on this, please let me know. Somehow seek out your teacher, ask a question, right? Otherwise, let's move on to the next part of this. This finding a solution, by the way, is an important part of what we are doing today when we are graphing. So let's talk about the graph of a linear inequality. So when we graph a line, what we are really doing is putting a point. So I'm just graphing this in slope-intercept form. The line represents all points that make solutions. Now, this is important because what we are looking at graphically is a representation of every point that makes this a true statement. So every single combination of x and y that makes a true statement is represented on this line. Let's take a quick example. This point right here is 0, 1. So this is 1 equals 3 times 0 plus 1, which is 1 equals 1. That's a true statement, okay? This point on the y-axis that we found is a true statement. What about this one up here, 1, 4, right? 4 equals 3 times 1 plus 1. This is 4 equals 3 plus 1, which is 4 equals 4. It's a true statement, okay? The line, even these decimal ones in between, all of these represent every set of x and y that makes a true statement. When we are graphing a linear inequality, we are looking to do the same thing. We want to find all possible combinations of x, y that make a true statement. Which means that there are significantly more things that make true statements. Because remember, this doesn't have to equal. It doesn't have to be 1 equals 1. It could be, if we're talking about a less than statement here, anything that is less than also works. So let's draw this real quick. And it's the same graph. It's the same exact graph. Where we're going to put this up here. I'm going to make this a less than or equal to real quick. So we draw in our line, and these points, just like the ones that were up here, are all going to work. Every point on this line is going to represent a true statement. However, there are a lot more points that will represent a true statement. Like, for example, let's plug in 0, 0. The point 0, 0, 0 is less than or equal to 3 times 0 plus 1. 0 is less than or equal to 1. That's a true statement. which means 0, 0 is a true statement. What about the point 1, 1? The point 1, 1, if I'm going to plug this in, is 1 is less than or equal to 3 times 1 plus 1, which makes 1 less than or equal to 4 plus 1. Oh, 3 plus 1, I did it again, which is 1 is less than or equal to 4. That is also a true statement. 1, 1 makes a true statement. Notice how, because of the inequality sign, we have lots of true statements. We need a way of representing all of the true statements. So we have a way of representing all of the true statements. We have mathematicians have invented this method to show all true statements. And what it is, I'm erasing all that stuff, is shading. So shading represents all true statements, also known as solutions. Okay? So this here was a solution and this here was a solution. This down here is also going to be a solution. I don't even know what point that is, but it's a solution. This point's a solution, and this point's a solution, and this point's a solution. In fact, everything on this side of the line will be a solution. So what we do is we shade in this region over here, because all of the things on this side of the line create true statements. Picking points on the other side of the line doesn't work. Let's just do an example. This point right here is 0, 4. 4 is less than or equal to 3 times 0 plus 1. That's 4 is less than or equal to 1. That's false, right? Everything on this side of the line is going to be false. Everything on this side of the line is going to be true. So we shade the true statements. Let's do some examples. Y is less than or equal to -3. The first thing we're going to do is draw this line. 1, 2, 3. And then we draw the horizontal line. Choop, choop. Choop, choop. So, which side is true? Well, Y is a number smaller than -3. So, any number smaller than -3 will make a true statement. So which side of the line is smaller than -3? That would be this side of the line. So I shade this side of the line. Everything on -3, the line -3 works because -3 is equal to -3, and everything below -3 is going to work. What about this example over here? This is x is less than 2. So here's 2, and here's my line. Oops, that was a terrible line. Not even close to what I needed it to be. And here's my line. What about the points on this line? If x is equal to 2, let's take this point right here and see if that's a true statement. This is 2, 1, right? If I plug in 2 for x, I get 2 is less than 2. Is that a true statement? No, it's not. This is false. The points on the line, because this is not equal to, like this one was equal to, so everything down here on this line works. This one is not equal to, which means things that are on 2 don't work. We have a special way of notating that. The line is not going to be a solid line. When we have a false statement on the line like that, we notate that with a dotted line or a dashed line, because 2 is not a true statement. It is false. What about 1? Well, 1 works. 1 is less than 2. That's true. 0 is less than 2. That's true. So points here and here will all work, but not the points on 2. So we shade the side that is true statements, and that's this side. But the dotted line is not a true statement because x can't be 2. 2 more examples. Let's do these 2 lines here. We're going to graph the line, and we graph the line the same way. Oops, I don't know why I drew a dot there. That doesn't belong. We graph the line the same way This has a y-intercept, right? This is like y equals mx plus b. This has a y-intercept of 0. It's an example of direct variation. Then it has a slope of -2, down 2, right 1. Okay? Notice that it's a greater than symbol, not greater than or equal to. So I'm going to mark this with a dotted line. And then I have to decide what's the true side and what's the false side. Well, I'm not really sure. So I'm going to just pick a test point. We're going to test 1, 1. And let's see if that's the true one. If 1, 1 works, then everything on that side will work. So 1 is greater than -2 times 1. That's 1 is greater than -2. True statement. So because 1, 1 was true, everything on this side will be true, and we're going to shade this side of the graph. Finally, the last one we have here, we're going to graph this here in standard form. We're going to use the trick about finding intercepts to graph it in standard form because that's the fastest way to do it. We're going to, for just a second, right? Remember, what we're going to do is ignore. We're going to ignore this, right? We plug in 0 for x. Plugging in 0 for x, ignore that. We get -2 is less than or equal to -4. That's +2, so I have a point there. Now, we're going to do the same thing, but we're going to ignore that one. Plugging in 0 for y, we have 5x is less than or equal to -4. That gives me x is -4/5, so that puts a point right there. And then we connect the dots. This is a greater than or equal to, so it's a solid line. And then we got to decide which side to put it on. Well, which side is going to make the true statements? Let's pick a test point. We're going to test 0, 0. 5 times 0 minus 2 times 0 is less than or equal to -4. That's 0 is less than or equal to -4. Is that a true statement? No. That is false. 0 is not less than -4. So, since 0, 0 is false, everything over here is false, and we shade this side of the line. All right, that was a lot to take in on this video, but I want you to try a couple of practice questions. And again, if you have a hard time with them, make sure you contact me so we can work it out. Okay, so go try there's 4 practice problems for you, and then we'll see you back here in just a couple minutes.